Hello class, welcome to Unit 5.1A, Solving Inequalities. So when we solve inequalities, it is just like solving an equation with one special rule. The rule is, if we multiply or divide both sides of the equation by a negative number, then we are going to flip the inequality. So let's take a look at what that looks like. Okay, so example 1, we start just the same we would if we were just going to solve an equation. So we always use those inverse operations. So if we see plus 10, we're going to subtract 10 from both sides. And now here's the part where we need to divide both sides by negative 2. The first thing we want to do with that is flip your inequality. And once you flip that, so the rest of it's just like normal. So here's the inequality we're dealing with. And then, of course, that's going to require us to come down here, negative 5, no equal sign, so that means it needs to be an open circle, and then anything that's greater than negative 5. We look at the next example. Again, we start with adding. Do those inverse operations. Get negative 1. And then we need to multiply by 5. And because we're multiplying by a positive number, we are not worried about that sign. In this situation, we're now going to have x is less than negative 5. So, again, with the open dot and anything less than negative 5 will do the trick. Okay, take a look here. Those are two easy examples here, but it's a solve and graph. All right, pause here and practice these problems before we move on and check our work. Good luck. Okay, looking at Unit 5.1A, Intro to Compound Inequalities. So we're going to have like a little part 2 today, where these are going to start by solving your compound inequality, and then we just want to simplify our solution. So the compound inequalities are going to either have an or an and statement connecting two things. Now, all of these examples are going to be already solved for us. So when we get down to the possible solution, we just want to focus on what this actually looks like. So when we start graphing these, it starts the same way. And we say when x is less than 3, that's going to go that direction. We're also going to have, say, or x is less than 7. So that is going to go that direction. Now, if it can be either one, it could be less than 3 or less than 7. What we are going to want to do is be able to look at this and say, if it is x is less than 7, that is going to include everything that is less than x is less than 3 as well. So what we don't really need to see is this part of our equation. If you'd be looking for a simplified answer, all you'd be looking for is anything less than 7. Now, when we think back to that definition of how we did probabilities with and, well, we could start the same way. X is less than 3 and x is less than 7. Well, and is always where it needs to be overlapped, right? We need to make sure it's both of them. So what that's going to do is saying it needs to be less than 3 and less than 7. Well, that means anything up here cannot be a solution. So all you'd be looking for is anything that is x is less than 3, because any number that's less than 3 would also be less than 7. Okay? Okay, look at the same ones. If we're going to say x is greater than 3, that's going to go this direction. Or x is greater than 7. Okay? Now that we're using this or, it doesn't matter which one it is. It could be greater than 3 or greater than 7. So we don't really need to have them because they are all included in your solution that x is greater than 3. You do the same thing with x is greater than 3 x is greater than 7. Well, now that we have this and statement, well, all of these numbers here, 3, 4, 5, 6, are not going to be greater than 7, and we need it to be both. So anything that is x greater than 7 would be our solution. All right, let's look at the other 4. Okay, if we have x is less than 4, or x is greater than -2. So now we got two arrows going both directions, and both of these lines are going to extend forever. Now, the fact that it's or could be either one, this is now going to include everything. We got arrows going both directions, so this is going to be an x is equal to all real numbers. Now, if we look at that a little bit differently and say x is less than 4 or x is greater than -2, so x is greater than -2, well, now these two lines kind of go back and forth. Now, they would go over forever, but if we're saying and, when it's going this direction, that is no longer both of them. Or if we go over this way, that is no longer both of them. So what you're going to be left with is one of these compound inequalities where x is going to end up between the -2 and the 4. So if it needs to be both, it needs to be both greater than -2 and less than a 4. Or if we look at it a little bit differently here, x is less than 1 or x is greater than 6. Now they're going opposite directions, which is fine. But in this case, now your answer is really just that, because it could be either one. It could be less than 1 or greater than 6. We look at the x is less than 1 and greater than 6. Well, is it possible to have a number that would be less than 1 and greater than 6 at the same time? This is going to be a no solution. So, when you look at your examples, the biggest key when you see some of these compound written out, ands or ors, what we're going to need to do is just take a quick solution and go from there. Now, probably the two most popular ones are going to end up being this one and this one. It's usually going to be either one that connects in the middle or one that goes opposite directions. But there are some possible times where you might end up with some no solutions, all real numbers, or even might have to simplify the two into just one. So take a look at some examples. Good luck with the practice. Make sure you pause here, practice these. You will notice that you will have to do some quick solving, dividing by some negatives, just to get those simplified inequalities. And then you need to make sure you practice graphing and interpreting your results. All right, good luck. All right, take a look, check your work. If there's any confusion, we'll make sure we ask some questions in class. Have a good day.